friends. Let's do this. Okay, how many locations did we sample? 50. And how many were water? 30. The proportion of locations from our sample, our p hat, is 60%, right? 30 over 50. All right. So now it says construct a 95% confidence interval to estimate the proportion of earth that's water. All right. So what we're going to see is an outline of how you're going to work these questions from here to May. And this outline works for a lot of different questions we cover for the FRQs that you will see. So you'll get really used to this, all right? The first step is the state step, where you state the parameter that we're trying to estimate and the confidence level. So the parameter means we've got to put it in context. What is it we're looking for here? P, the proportion of earth covered in water. At what confidence level? 95%. The next step that we have to go through is the planning step, where we identify, and this is something you already do. You have to stop and think, what am I going to do? How do I do this, right? You already do this. We're just writing down the procedures, and this is going to help ensure that you have every little detail down and you get full credit on your FRQs, all right? So name the procedure. Right now, this is your very first procedure. We will end up with 12 procedures by the time we're done. The first one today in this chapter is the one proportion Z interval. Obviously proportions, and it's Z because we're using the normal distribution. Okay? Checking the conditions. We kind of revisited these yesterday. Do you remember what the conditions were? Okay, random was the first one. What was the next one? 10% condition, and then what was the third? Large counts. And the purpose of that is to know, is it normal? Okay, so let's revisit. Was our sample random? Yes, very, right? All right, we had 50 locations, 10%. So now we stop and say, is 50 locations less than 10% of all locations on the earth? It sure is, right? Could be infinite locations on earth, right? Normal, how do we check normal? Large counts test. Large counts test. So remember, we're going to use our sample size times the p hat. Our p hat was 0.6, right? So that gives me 30. That's greater than 10. And then 50 times the complement. That's greater than 10. So we know it's approximately normal. And that's how you can shorthand it. Max, Trenton. Okay, that's the planning step. Do step. That's the one that you all want to jump to, do the math, right? So this is where we perform the calculations. So the general formula we're going with here, you don't have to write this every time. I'm just going to write it because we're still learning it. P hat, remember that's our point estimate. It's where we start with our sample data. Plus or minus the Z star, critical value, times the standard error that we discussed yesterday. Now we're going to plug in our numbers. Do we have all these numbers? Do we know what P hat is? That's 0.6. Do we know what Z star is?
No.
How do we find it? Remember? All right, let's do a little sidebar. Let's figure it out. 95% confident means 95 goes in the center.
Oh, yeah, that's right. And there's 2.5 on each side. So it's
0.025, right? When you make it a decimal. Yes, 2.5% on each tail. You're right. So when you put it in your calculator, be careful. Don't put 2.5. It'll give you an error. But 0.025. And then remember, you go to inverse norm. When you do that, it's going to give you negative 1.96. But remember, we use positive and negative because one is positive, one is negative. So there's your Z star. This is one of the most commonly used ones, and you may very well memorize it before you're done with the chapter, okay, because you see it so much. Now we have all our values to plug in. So p hat is 0.6 plus or minus our Z star, and we can plug this in. And n was 50. Now we do some number crunching. Don't round your decimals to the very end, and then I would suggest rounding to 3 decimals. Okie doke. Did y'all get that? Huh, interesting. 75% is not in there, is it? But 70% is, so. Do you think it's an exact number? You think they know exactly how much of the earth is covered in water?
No.
No, it's just an estimate, right? So fairly decent confidence interval. Now your last step of the outline is to conclude. This is where you put it back in terms of the parameter. All right, what does our sentence start with when we interpret an interval? Do you remember? We are, yes, we are. We, as the AP Stats class, we are.
Okay, but like.
As statisticians, we are.
Oh, just, okay.
95% confident that the interval from 0.464 captures the true proportion of Earth covered in water. Can we handle it? Anytime it says to create a confidence interval, to estimate, blah, 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 we do the 4-step process. It goes fast. Right now it's slow because it's the first time we're doing it, okay? But it does go faster, and you will get this thing memorized before you know it. And it'll be secondhand to you. Now, look at number 4. They're throwing us a little bit of a curveball. It says, how many locations would we have to sample if we wanted our margin of error to be only 2%? So remind me, where in my equation is the margin of error? Do you recall?
It's the Z star times the standard error, right?
Yep. This whole thing is margin of error. So if I know that that needs to equal 0.02, what part of this equation am I solving for? It's not Z star because we're still 95% confident. That's not changing.
The N?
The N. N is sample size, right? How do I know that? Because it says how many do I need to sample, okay? So we're going to use our equation. We're going to set it equal to 0.02. 1.96 is still there. We're going to still use 0.6 and 0.4. The unknown now is that sample size. Now we're going to have to do some algebra and untangle that in, aren't we? Do you think you need to show the work? Of course. We don't do naked answers. Of course you do. All right. What would my first step be? Divide that 1.96 out. Okay. You can definitely cut your decimals as you write it on your paper, but don't round until the very end in your calculators, okay? Okay, so I get what would you do next? You're going to have to square both sides. So 0.6 times 0.4 is 0.24 over n. So if I solve that for n, it's going to be 0.24 divided by this large, really actually very small number. So that gives me 2304.96, not.
You know, it's crazy, I was thinking, I haven't used algebra 2 at all this year. I was saying that earlier today.
You're about to, aren't you? This is just algebra 1, honestly, though.
I don't even remember.
Okay, now, there's a conversation here we need to have. We're looking for a sample size, right? Can you have 0.96 of a person? Or somebody you need to sample? No, you either sample them or you don't, right? It would be a discrete number. So we need to round this to a whole number. So the question becomes, should we round up or down?
Up.
Why do you think up?
Because it's only 0.04 away.
Okay, I'll give you that. But, so 2305 is my answer. If you leave it in decimal form, you will get it wrong. But here's the caveat. Look, here's the logic, I should say. Let's say it came out to 2304.0001. So you're telling me I should round that down?
No,
Why not?
because then it's going to be less than 2%. Or, no,
It'll be greater than 2%, right?
Yeah.
Why is that? Because this indicates that 2304 isn't quite enough, isn't it? It doesn't matter if there's 12 decimals here. If there's something out here, we always round it up because as we know at this stage, it's better to have more in our sample than too few, right? So the rule of thumb is when we do sample size, we always round it up, no matter what the decimal says. Okie doke. Questions about that? All right, let's go to the back. Let's summarize this stuff. Four-step process. First time you've seen it. This doesn't take long to fill out. The first step is the state step. It's very important that you state the parameter in the context of the question. And with confidence intervals, we want to state a confidence level. The plan step is to name the procedure, and just to remind you, we're doing one proportion z intervals. And then you got to check your conditions. Okay? The do step is the math step, where you show your work every time. And the conclude step is where we take it back and put it in context. Make sense of the numbers that we just generated. What does it mean? Okay? Then the other thing that was new objectively about this lesson was finding a sample size. Okay? What if they don't give you a sample size? They just tell you the margin of error. You just need to remember that margin of error consists of the z star times the standard error, right? And you solve it for n. So where do you get p hat? Sometimes the question will give you p hat. Sometimes it won't. So what do you do if it doesn't? Well, this is where, if it's unknown, we use 0.5. It's a conservative calculation. What it's going to do is make your sample size really large just to make sure you got enough, okay? So if it doesn't tell us p hat, this is what you default to. If it does, then use the one that was given, okay? And then this is that last thing we said, that if n has a decimal, we always round it up. Always, always, always. All right.
What happens if you use a 0.5 and one doesn't have it?
You're going to get a different sample size than you needed. It's going to be a lot larger than you actually needed. So, all right. You're going to see how that plays out because we're going to do it both ways in this question. So look at this. Community activist group in Austin wants a particular issue to be placed on the ballot in the upcoming election. To make it on the ballot, 20,000 valid signatures are needed. The group turned in their petition with 24,598 signatures. To pass the validity test, 20,000 of them, or 81.3% of those signatures, have to be valid. Well, it's too time-consuming to check all of them, so a random sample of signatures are checked. The individual checking their signatures needs to be 95% confident that the true proportion of valid signatures are estimated with, at most, a 2% margin of error. So A says, using the conservative estimate for p hat, how large a sample will we need? Okay? So we're going to use our margin of error equation, and we're going to use 0.5 as our conservative estimate, remember? So 0.02 is what we need it to be. 95% confident. Anybody remember what the z-star value is for 95?
1.96.
Good, 1.96. 1.96. Most commonly used one, so you didn't have to recreate it. But there it is. Okay. Conservative estimate is 0.5 times 0.5 over n. Trenton, you should be doing this with us. How do we do? Did we get there? Yeah, we okay? I will tell you this, if you somewhere in the process, like if you start rounding your decimals, your answer is going to look different than mine. Because I don't round any decimals in my calculator, I don't cut anything off in my calculator until the very end. Keeps it more accurate, okay? And if yours is off a little bit, like if you ended up with 2402, that's okay. That's where showing your work is really important. If I see your work, then that being off right here just means that it's just a matter of rounding somewhere in the process. Nothing to be alarmed about. All right? Yeah.
Would we need to show the calculations for the critical values?
No.
If it was a memorized one?
Yeah. You don't have to.
Okay.
You don't have to show that. Other questions about it? Kendall, you look confused.
I'll go over there in a second. I don't know where.
Did I lose you somewhere in here?
It's like the last two steps. Like I have 0.0001 and then equals 0.25 over n. And then I end up with, I don't know, like I have.
I just multiplied both sides by n to cancel this one out. And then I divided that 0.00014. All right, if you're ready, look at B. B says we're doing the same thing, but now we have 85%. We have an actual value for p hat. So we're going to do the same thing, but what's changing is these values right in here. We're not using 0.5 anymore. We're using 0.85 and 0.15. So you're going to see how different your numbers come out if you use the actual values. Okay? So let's crank it out. Do it again. If the company's president demands a 99% interval instead of 95, would this require a larger or smaller sample size? Assuming everything else stays the same. So don't go calculating. Just think about what's changing about my equation, okay? If my margin of error stays the same, what's changing in my equation on the right side? Is the z-star changing? Yeah, it is, because 95% confidence is the 1.96, right? Do anybody remember what 99% is?
2.04.
No, 2.576. 2.576, which you can find that on your own. If you don't have it memorized, it's fine. Everything in the radical is staying the same, isn't it?
Yes.
So what is that going to do to my answer? It's going to make it bigger, right? Because look, this number got bigger, didn't it? So it's going to make our sample size bigger. Does that make sense that we would need bigger samples? Yeah? Because it's ultimately, remember, a 99% interval is going to be wider, isn't it? Yeah, it's going to make a larger sample. Our first thing is right. Okay, so a larger sample. To be more confident. They have to check more signatures. That's really all it's getting at.